New capacitor inserted. I've not bothered cutting the legs because as soon as I've got this thing displaying a proper TV picture, all the replacement parts are coming out. This is just a resurrection, not a restoration. So right, do we have any difference on the picture? Wait a minute or so for the tube to warm up. Switch my light off. Probably no difference. No, okay. Something solid state then that we need to have a look at. Something that's a transistor or resistor, and I'll be doing that. Probably I'll be doing that tomorrow, if you excuse the burp. I'll be doing that tomorrow because I've only got 3 minutes of recording time on this camera, and it's nearly my bedtime. So go to bed early, get up early. That's what I like. So yeah, we'll test all those, test the diodes and the other transistors in the frame stage tomorrow. One more thing I nearly forgot to explain. The reason why I've not checked either of the height or vertical hold parts at the moment is because they are both kind of set midway right along the travel. Right, so because the knobs, they're kind of like set midway, so they're not at either extreme. So I don't think it's just maladjusted pots. It may well be, in fact, that's another thing I'll test tomorrow. It may well be flaky pots, potentiometers, knobs, controls, whatever you want to call them. But I don't think that they're maladjusted, which is why I've not adjusted them. Following day, right, and I've just tested this one, and this one's also drifted. That's supposed to be a 4.7 microfarad. It's actually measuring, well, that converts to about, well, almost 5.9 microfarads. ESR is, well, the ESR is very good. So, but it's doubled in value. Well, not doubled in value, but it's behaving like a 5.9 microfarad capacitor when it needs to be 4.7. In case you don't know, farads is the unit of measurement for electrical charge storage in an electrostatic field, not in an electromagnetic field, which I believe is measured in henries. So 4.7 microfarad. What voltage? What voltage is it supposed to be? Sorry, this thing is so tiny. 63 volts. Fortunately, I seem to have 10 47 microfarad 63 volt capacitors, actual electrolytic capacitors. Sorry, I meant 4.7 63 volts, and I don't have any new ones, one used one. Maybe I can try finding that 4.7 100 volt one, maybe, or the 200 volt ones, or the 400 volt ones. Okay, so apart from the 25 and the 6.3, all of the new ones I've got, plus a couple of the used ones, would be fine, just for using temporarily before I pull this thing apart. This one was just the first I could grab that was the right size and could handle the voltage in this. 4.7 microfarad, maximum handling of 200 volts. Right, new capacitor inserted, let's give it a go. Fat lot of difference it made. Right, We'll be looking at the transistors next. Oh yeah, and also I said last night as well that we'd look at whether the pots were very dodgy, didn't I? So yeah, transistors and pots next. Right, slight change of plan. I will check these resistors first. I think I know that one's okay. We'll check these, then the pots, then the semiconductors. Right, resistor to what was it? 725. That's dropping 28 volts from 38 down to 28. Okay. Then resistor 721 and then 716. 721 only has 10 volts, 220k, and then what does 716 have? 716 is about 18 volts, and that's 100k. 28 down to 18. Oh no, sorry, 38 down to 18. Okay. Right, so okay. Generally, none of them seem to have gone higher than what I would expect, at least. Okay, because if they'd gone higher, then the voltage drop across them would be lower. Right, so just measuring the resistance across those resistors. 716, meant to be 100k, actually measures about 120 on there. I've not desoldered one leg yet, but in the past, usually when I've tested a resistor with both ends in circuit and it measures high with them both, still with both ends in circuit, then that usually means that the resistor has gone high. Okay, so I'll be checking that one in a moment. 716, 721, 220k. What does that actually? Okay, 721 is meant to be 220k. Actually 191 with both ends in circuit. Okay. Okay, and then 725, that's meant to be 2.2k. Right, so 2.2k, 721 we said, wasn't it? Let me just struggle to get this connected up. There we are. That measures bang on. Okay, so I might need to check that one. So 2.19, that's close enough to 2.2. Right, so I want to check resistor 716. Also, just while we're at it, let's check that one. 709, yeah, I know the camera work is crap. 709, 709, I saw that earlier, there it is. It's this big one here. That one. And that one measures 0.72. Yeah, that big one there measures 0.74, and it is meant to be 1k, but don't forget it's in circuit, so it's in circuit, so the other components still being connected up will distort the readings. Sorry, I'm still yet to get used to using this viewfinder on my camera as my eyes, so that you see what I see rather than just me looking over the viewfinder. Also, let me just check that one and that one. Oh, and I'll also check that one anyway. Right, so 705, 2K2, 713, 39 ohms, 724, 330 ohms. I'm not too concerned about the resistors at the bottom at the moment, because I don't think that they would cause a reduction in height. I don't think. Right, so because this seems, a reduction in height seems kind of low voltagey to me, right? And there's a resistor down here would not cause a low voltage. A resistor up here, or there, or there, would cause low voltage at some point to be reaching here. Might also be a good idea to test those actually as well. Right, so resistor, let me just make a note of it. Resistor 716 is suspect, as is 725. 716 is definitely suspect. 725 is probably around about 50-50 suspect, I would say, because it measured bang on and not low. So yeah. Also, I want to have a look at that one, because that comes from the sync separator and then feeds into the frame oscillator down here, down here, down here, down here, down here, down here, and also that one as well, 702. So we've got a lot of resistors to test. Okay, that is a list of the resistors that I've tested. Some of them are okay, majority of them are about borderline, and then there's one which is resistor 716, which is a big suspect, because that measured way above what it should do. And one more that I spotted, resistor 611, which is high, 28, it's supposed to be 22, or at least it tests high in here. It tests high when it's in circuit. It's not a true reflection of what the exact value is, but as I said earlier, usually when a resistor is high, it will, in circuit, usually either tests high in circuit or bang on its value in circuit. See, I thought that resistor was high. 118, well near enough 120, and it's meant to be 100. Because there are no component markings under here, it's easy to get confused between, especially when you've got a ladder of components like that, look. It's easy to get confused between two of them, even when you're absolutely sure. And initially I had unsoldered a diode that was next to that resistor that I've just shown you. The diode is that one there, and it tests absolutely fine. Right, so we can rule that out. That tests okay. And resistor 611, which is that one there, actually measures 29k, so that is letting through less voltage, less current if you like, less voltage, current, whatever. It's letting through less voltage than it should do. Right, so yep. And what is that? Carbon resistor, I think. And the outside just looks like plastic or whatever but on the inside it's carbon. New resistor put in, or resistors put in, for those two. Let's see if that makes a blind bit of difference. No, it doesn't, because I've forgotten to plug the detachable mains lead in. Right, still no difference. So we need to look at those transistors, I say. In fact, no, let me stop contradicting myself. It was the pots that I said that we wanted to test next, wasn't it? Well, the DGOS fired that time. I just want to check something, because I think I noticed that the picture wasn't that high still, but was it still flickering as much? Okay, well, not to my eyes. Okay, it doesn't seem as bad. Right, okay. So I think we had two separate faults then. That feeds the vertical hold, the frame hold, so it wasn't. So now the TV is producing an image at probably around 25 frames a second. Probably a little bit low, but right. So yeah, we have fixed the fault, so it's still got better then. So now we just need to get the height working. So yeah. So I want to check. I've already checked that diode. It's fine. I want to check that. So this looks like, yeah, it doesn't really look like there's much to it for diagnosing these. I also, however, first want to check that, and then those. The height control being set at one extreme won't have helped, will it? Has that made any difference? Oh, little bit. Right, there's no, you see, because remember there were two fat white lines along the bottom of this, and I know that you can't really see it in the camera screen. You can't really see it at your end because I'm looking in the camera screen. It just looks like a white light, but now we managed to get rid of that top one. Yeah, this almost certainly is a transistor fault, I think. Now I will just go through and test the other parts, but we know that one's not suspect because that's the frame hold. It doesn't have anything really to do with the height, so I want to look at that one, and that one. But I think the main suspect is probably going to be one of these transistors. There's no... You basically have to test everything. Oh, now, see, the frame stage, the vertical hold is now going way off. That is visibly flashing, to my eyes, worse than it was when we actually started. Okay, so I'm looking for these two. That one tested. Well, it doesn't test, but I've readjusted it slightly. That one and that one are what I'm looking for on the board. It's not one of these. I've looked. I had to scrape away some dirt just to see the component numbers. It's not that one. That one's 761, and it's definitely not that one. That's the line shift, so it's nothing. So I think it's in here. Hang on, well, I've spotted them. I've not spotted what I'm looking for, but what they could be. Oh dear. Right, these are potentiometers as well. These are skeleton pots. I got a feeling of dread when I saw these, because I've come across these before a few times in a early 80s Thorn TX9 portable that I used to use as a main set for a while. And I've actually had a couple of TX9 portables, and I think the larger TX9s used them as well. These now, they may have been good in their day, but now I'm finding that these are starting to go open circuit, and the wiper stops making contact on them and all sorts of other stuff. So I guess I've got to look for some of those. and I can't seem to find them on here. To be in there. To see with my own eyes. No. Let me have a good look for them. Or alternatively, they may be stood up like that one there as well. Spent the best part of what, 15-20 minutes looking for them, and they're right in front of me. I'm having another one of those days. Right, both of the transistors that I need to have a look at, which are 722 and 704, are both lock fits. Remember from earlier, I think I explained these wedge-shaped transistors. Lock fit is not a specific part type or part number or whatever, it's just the name that Mullard gave to their range of, to their design of different kinds of transistor when they started building them. That's a BC148, if you can read upside down. That's a BC147. Lock fits are, as I said, they are wedge shaped. And they are usually very poor quality, judging from the reputation they have. I'm trying to remember their failure mode. I think I remember once reading that it's because of poor manufacturing. The seal between the black plastic body of the transistor and the legs underneath was not very good, not very well sealed, so moisture could set in. I think that's what I read. It was a long time ago. Don't take that as gospel. If you're really interested, probably check it out. I don't know, whatever. Lock fits, in case you don't know, were made by Mullard, who were part of the Philips empire. And yeah, they were owned by Philips, who were part of the Philips empire. And Pye, Philips at this time that this set was made had very strong links, very strong relations with Pye, and a few years after this was made they would completely take over Pye. I think it was 1976 that they took over, so it's not very surprising that they used Mullard built components. I think some other manufacturers used Mullard transistors as well. I know that Thorn did. Thorn had were in no way owned by Philips or even related to them. Yeah. Right, so I've tested the BC148, which is that one, and when I pulled it out, one of the legs came off. Right, but fortunately there was a bit of a stump that I could hook that onto, and I've just realised I've just put that in the wrong thing. Hang on. Anyway, and surprisingly, that still works. I've already tested that one, the BC147. That also works. I'm not really sure that HFE figure is right though. I think that HFE is how sensitive, if you like, the transistor is to the signal that's coming in to the input. I think that's what it is. I can't remember. Well, that resistor being dry jointed is not going to help, is it? That's not going to help. Resistor is that. 707. where on here is 707, 702, 705, I think we're close. So it's at 707, okay. Is that part of the integrating circuit? I don't know. I need to read up fully on the theory behind this, but also, so let's touch the soldering up on that, and I want to check that. Is that a double diode or something? What is a BR101? It appears that it is a bridge rectifier. But with those lock fits, even though they test okay, something at the back of my mind tells me that got a vague memory of reading that even though lock fit transistors can test okay, they can actually still prove faulty because they fail in a way that testing equipment doesn't really. They fail in a way that testing equipment doesn't really look for, especially the cheap stuff that I've got. 2 new transistors fitted. Let's see what it gives us now. If it's still giving us the same results, then I'll want to have a look at that. Oh yeah, and I've also touched up the soldering on this as well. There's not much difference. Right. I mean, it is kind of expanding a bit, but I've just adjusted the frame hold, and there's no flickering at all now. Well, there is a little bit in the camera, but there's no flickering at all now, so that means that the oscillator is working. I wonder, because I replaced that, towards the start of this epic, I replaced that along with that and along with one of these two. Then we had all the shenanigans with me not fitting the mica dropper, the mica mica sheet, which killed one of the other transistors. I'm wondering if that's been damaged as well. Because this seems like it's the oscillator here. Maybe that's some kind of driver transistor, and then the output transistors there. Maybe. Let me recheck that. I know I replaced it, but I'm wondering if that got damaged when we had the shenanigans with these two. Right, so I've been twiddling all the pots for the frame stage, and we have no difference at all. The only one that seems to make any effect is that frame vertical hold. Notice how it's twitching now. And that was just after me just adjusting that height thing. Is the height pot open? Well, I've just tested it. That transistor has survived. So it's not that. It's got to be the pot then. Let's try replacing the pot. Sorry about the tumble dryer in the background, you'll just have to bear with it. But yeah, this thing drove me mad for a bit. Right. Turns out, when I was measuring one of the resistors, one of the legs had partially come off. One of the ends had partially come off rather, and I didn't notice it. right, and it sent me in a wild goose chase, and managed to fix it. Not only is it fixed, but it's a bit better as well. Right, okay. So it seems as though some of the transistors also needed changing too. A few days later, right, I did work on this yesterday and didn't update you because it sent me on a merry-go-round, which would have just been boring for you lot. But basically, yeah, no, a lot of the soldering is now starting to suffer because I've had to. A lot of the solder pads have started to suffer because I've had to unsolder and resolder and replace so many of these things so many times over. So because there was a shorted, so there was a solder bridge on there which was down to my ham-fistedness. Now looks fine. Well, as fine as, well, yeah, whatever. But it now looks mechanically sound at least. But I had to replace that, which is the Pye CT200, because, again, when I'd replaced that previously, I'd left a solder bridge there without realising. So that had short-circuited across there, which then had a cascade effect on these two, we assume, because these are both the frame output transistors, and that's the frame driver, the Pye CT200, BD233 and BD234 there. So they had both suffered, or seemed to have suffered something. So I changed that, and that, and that. Didn't change the two frame oscillator transistors simply because there's a blocking capacitor between them, so if something here caused damage to these two, it's unlikely to have fed back to the others. But change that and that and that, and no difference. Now, here is where I spoke to Chris on the UK Vintage Television Collector Forums, sorry, not Collector Forums, on the UK Vintage Television Collector Facebook group. And basically I was as open to him as I have been to you lot. I'm completely new to transistors. I did not know, I knew that there could be a cascade effect to transistors if you got things wrong, but I didn't think that they would be that sensitive. So that's a lesson learned. He said that that it might be best to scope it up. Now, I've not learned how to use that. I really do need to learn how to use one of these. I've only ever tried it in the past and just had a little play around with it, but I've not properly learned how to use it. I mean, it makes a dot on the screen, that's all I know when I switch it on. Right, so before I do that, I did a little bit more testing. Remember that diode that I'd tested? That initially, a few days ago or whatever, tested okay. And now it's measuring like a 137 ohm resistor. Even if I put it on diode measurement, it's nearly the same. That should measure open one way, and it's a signal diode, probably about 500 the other way, around 500. But no, I've tested it both ways. It measures 137 ohms one way and 115 ohms the other. So I think that that is on its way out. So that must have started packing up after I replaced both of the lock-fit transistors. So So, and in my mind it's behaving sort of like a leaky capacitor, in the sense that it's starting to pass current through it in both directions, unlike a capacitor which isn't supposed to pass current in either direction through it. A diode is only meant to pass current one way and block current the other, but to me it sounds like it's passing current both ways. And when I tested it last night on this, it measured, well, this thing couldn't decide whether it was a 115 ohm resistor or a 38 picofarad capacitor, and that couldn't make head nor tail of what it was. It kept on saying unknown / faulty component. So now I just need to decide, did that fall by itself, or was it pushed? So did it fail by itself? Did it fall? Right, or did something else failing then push this, cause a fault? Did something else failing cause a fault condition with voltage, higher voltage and current, which then caused this? I need to check the circuit for that, because I mean it's all well and good me just putting another BA154 in there, but what I don't want to do is for me to then put another one in there and then that go very shortly as well. So let me study the circuit diagram. Do you think that is meant to be a diode? Because this is saying it's a 26 picofarad capacitor. Oh, and now it's saying it's a resistor. "100 ohm resistor", or 130 ohm resistor, whatever. So that is meant to be a BA154 diode. We are a few days later. I did do some work yesterday on this, right, but because I was trying to trace the short, I was sorry, let me start again. Right, because I had made a solder bridge on that transistor there, which is that one there. Right, I had unintentionally, obviously, made a solder bridge short on there, because I'd replaced the original with another, and without realising I'd caused, so I'd replaced the original with another, then we had the shenanigans with both of these, then because I thought that using one of these, one original, one new, with a new one of these could still have damaged it, I then replaced both of these and still kept that. Then that stopped working, so we replaced that. Just trying to see if I've got the steps now, because I'm just as steps right in my head, because I'm just as confused as you are. So we replaced that. That then led to a solder bridge on there, but I didn't notice that. So at first, yeah, I know that the soldering there is really shonky. I've also had to replace quite a few of these, because when a solder bridge was put on there by myself without realising, the frame collapsed completely. I know we had only about, what, 2 inches of height, 3 inches of height before. So then I started looking around these pots and testing a few of these, and indeed, you know, I had to take a few of them out and put them back, take them out, put them back, take them out, put them back several times, which is why the soldering is so shonky, because the solder pads were starting to lift. Anyway, I've made sure that there are no shorts there. Then I noticed that, and noticed that there was a short along there. So I changed that, and that, because these can have a cascading effect, because there's no coupling, no decoupling capacitor, DC decoupler between them. There's only one there, so any one of these three being damaged by a surging current like that brought about by a solder bridge is unlikely to affect any of these, because that capacitor will block anything fed back that way. Right, so I changed these. Still no difference. We still had a solid thin white line on the screen, complete frame collapse. That's when I started speaking again to Chris and Ian on the UK Vintage Television Collectors Facebook group, and let's let the dog tell the rest. Anyway, so translated, that means that I had got completely, sorry, the dog's starting to annoy me now. Right, but so anyway, I'd started having a chinwag with Ian and Chris, and the consensus from, I think the consensus was to start using that, diagnose it with that. And I had not, I've never used an oscilloscope before. I've switched it on and it produces a dot, and I can make the dot go across, but I've never actually learned how to use it before. Now, I don't think I will need another opportunity, at the moment anyway, to learn how to use that, because I then went back over original components that I tested earlier. That diode, which is that one there, had tested fine earlier. Now it doesn't even test like a diode, it tests like a resistor. 130 ohms on there. Unknown/faulty component on there. And it measures like a 125 kilo ohm resistor on there. Or, sorry, 125 ohm resistor, sorry. Yeah, 125 ohms. What does it measure on diode track? 116. So yeah, that resistor, as it is now, was diode, is shot. So I just need to work out, sorry, the camera works really bad. I just need to work out which of these components around it, or rather whether I need to, so I just need to work out whether that diode had died by itself, probably of old age, chemical compound inside breaking down and starting to allow current under, breaking down under current because it had got old. So I need to decide whether that had failed by itself or whether something else had failed and then pushed that. So, did this fall or was it pushed? My main suspects are, from top to bottom, probably those two equally at number one. That, I'm not really sure whether, I still can't decide whether that's a diode bridge or a thyristor, because yeah, I know it's got the diode symbol. Thyristor usually has 3 lines coming off it, one at an angle like that, but this one has 4 lines coming off it, so it might be a diode bridge, I don't know. It's not the usual symbol for a diode bridge though. But anyway, So that and that equally tops. Then I would say probably that, because I've not checked that, and that as well, equally in second place. Then that, because then that, because even though it's original, I've already tested it earlier and that was fine earlier. Then that, right, because I've already replaced that, could still have failed though. Then both of these, and then finally these and these. I've already tested both of these, they're fine, and then these. So let me start again, because I've kind of rearranged the order in my own head. So these, this, because I've not already tested them at all. Then this, because I've already tested them in the past and they were okay, and they're still original parts, so they could have gone. Then that, and then I would say those. I know I've replaced that. I know I've replaced some of these, but I don't think I've replaced all of them. I think, in fact, I can't even tell you which one has and which one hasn't been replaced at the moment without checking in the set. But yeah, so I think that these need to be checked first. But what I will do is I'll just throw caution to the wind, just put a new BA154 in first, just in case that had failed by itself. In fact, no I won't, because I need to go somewhere, need to go to an appointment now, so I'll come back to this later. Later the same day, I've just come back, found that the plug is not plugged in. I've just noticed that. I have changed the BA154, which is that one there, but I could not find, it seems as though I accidentally left off the BA154 from my order list for parts. So I've looked around in my transistor stash, which is not saying much. That feels like it's a bit loose. I need to check that, but and the only one that I think might work would be a 1N4937. Those who know more about diodes may, for all I know, may agree or may disagree that it will work. All we can do is give it a go. And we still have frame collapse. Nothing. I've spotted it. My mistake. This probably should teach me not to do these when I'm tired, but I have just put in, or a few nights ago, I had just put in a 220 microfarad capacitor in the space where there is supposed to be a 47 microfarad capacitor. That is, where are we? That is that one there. I feel dumb now. That is, I mean, I can understand, getting 4.7 microfarad or 470 microfarad, but 220 in the space of a 47, how did that happen? I must have been tired. That's the only thing I can think of. I must have been tired when I did the work to replace that. Right, here we go. Still don't hear any vertical output. No, still no difference. Finally started learning how to use this thing. Right, let me just, not sure why it's slightly tilted, but anyway, is it because I moved it? It was on, no, okay, whatever. But anyway, so yesterday, or I think the day before, I decided to do a little bit of investigation, right, and found out that using this was not as difficult as I first feared. Right, I'm still getting used to some of these controls, but I think I've basically got the gist of it. Now, I know that I'm using it correctly, at least, because when I switch the television on, we get, we did have the correct pulse from there, from the line output stage. Why is it not showing me that now? I remember twiddling about with that. Hang on one moment. Have I messed with this? Probably. There we are. There we are. So I don't really know why it's showing us double on there, but that pulse there on the line output stage, switch off so it doesn't burn an image into the screen, is, well, it's supposed to be that one there. It's a bit more rounded actually, because I'm not actually putting the pin on the on the collector of that massive BU185. I'm just sort of hovering the probe near it, but it's good enough, right, to know that that's as it should be. So so what I've managed to work out is that which is the output, let me just get it up because I've just booted this computer up. Where are we? There. So that waveform there is supposed to be what we see at the output here, between these two resistors, at the output of these two frame output transistors, which is these two big ones down here. What we actually get, if you give me just a moment, let me just grab the probe. What we actually get is just waveform. Hang on, let me readjust this. We actually get just sawtooth. There we are. Be very careful here not to fry this. fry the telly. Hang on. One moment, sorry. One moment. Oh, it's doing this again. What it was doing was showing a sort. There we are. You saw it just then. See if I can reenact it. See there? Does it when it's starting up and when it's shutting down. Sorry, does it when I'm switching it on and then switching it off, and then it gives up on the output stage. So it was giving us a sawtooth waveform, which is absolutely nothing like that. It's more like that really, but it shouldn't be giving us that there. That should be somewhat earlier. That's on the anode of the BR101, which is that thing there. And when I test over here, when I test on the test points there and there, the base of that and the base of that, what we should be getting is that and that, which is actually very similar to what we were getting at the other bit, but there's nothing. There's absolutely nothing. Right, so for instance, there is square root of diddly squat. It's flashing about a bit because it's really hard to hold this probe in place without slipping and then shorting something out. Right, so we're getting somewhere. I mean, we're getting a little bit of something on there, I suppose. But it just seems to be just a load of DC. There's no AC, so there's no waveform like there should be. Right, so I think we still have a fault in this stage. So the output stage is starting. It was giving us a sawtooth waveform because it has to apply a sawtooth waveform of some kind anyway to the scan coils, but then it's just shutting down afterwards. So I think we've got a fault here. The oscillator is not starting, so this tries to start, detects that there's nothing there, and then shuts down. So we've got a fault somewhere here. At least we know where to look now. Already replaced those, both of those a few times. They've made no difference. That is still original, so I need to check that I think next, and that will have to wait because I'm on a late shift. I need to get my arse in gear. I'm going to have to sort that out soon. Oh well, there's an improvement. That is all it was. So at least we're back. No, it wasn't completely fixed, but at least we're back to where we were before. Right, so that is what had failed. And there was me thinking that it had gone down to a completely thin line because of some kind of mistake I'd made. So yeah, this is the thyristor in the frame stage. Where are we? It's somewhere here. I just missed it because I looked away for just a split second. That had failed. I know that we're not ideally where we'd like to be, or at least where I'd like to be in how this set is progressing, but we've got somewhere. Right. We've made an improvement. Oh my god, that knocked it all out of me. Right, so that needs to go in there, the parts bin. Evening of Halloween 2024. Day that it was announced in announced by Transdiffusion, the vintage, who were the vintage British Broadcasting group, that one of a fellow YouTube archivist, continuity uploader, whatever you want to call him, called Oliver Ashmole has passed on. A couple of weeks ago, but maybe a few months ago from when you're seeing this, he posted a video saying that he was temporarily suspending posting new videos because he was having to go into some kind of, he was having to undergo some kind of surgery related to some cancer that he had, or that I understand he had. I may well be wrong, but unfortunately he didn't make it. And if I manage to get this thing working, then what I will do is I will post just a selection of a few clips from some videos that he's uploaded to YouTube in tribute. That's if I manage to get it working. I still need to complete replacing these capacitors. You see I've done most of them, but that one I've been waiting for the past few days to arrive. It has now arrived. It's upstairs somewhere because I've just realised I've come downstairs and forgotten to go and get it. I will need to watch out for a moment because I don't like trick-or-treaters. They just annoy me. But yeah, I need to replace that. I then need to replace all the transistors in the frame stage again. Right, and also I need to sort that out before I even switch it on. If we then get a full frame on the picture, a full picture or something approaching that, it might not quite be full even if I get it working, because I've been messing around with these, so I'll need to readjust these. But if we do get a full frame, then I'll continue on for us to do as much work as minimal to be able to get a picture, not just a raster like we've seen, but an actual picture on the set. If not, then that's a bit crumbly. It's very crumbly. If not, if we still get a line, or whether that be just a very thin one, or whether it be a line that's only about 2 inches high, then it's got to be the scan coils. Well, or it may even be something on the convergence board, because the output on a Delta gun set, which is 60s and early 70s colour sets, apart from a Trinitron because they were different, the output of the frame and the line stages have to pass through the convergence stage, through the dynamic convergence stage, before they are then passed to their relevant portions of the scan coil. Even though this looks like it's one assembly, there's actually 2 different scan coil assemblies. Well, it's one assembly, but there are 2 actual scan coils on it. The inner one, I think is the line, and then the outer one the frame. That may be wrong, but that's what my really flaky memory is telling me. And also, of course, I'm under the influence of my citalopram, which I have to take every day, which makes my memory somewhat, or my concentration somewhat murky. Just having a look at the EHT anode cap, which did go there. And it's actually not in that bad nick. I think all that's really happened then is that this sleeve has slipped down, which has then made this tape on the end come undone. Okay, that should be an easier fix than I thought it would be then. It only looked ripped, it because I don't know if you can see, but there's kind of like a rubber ridge there. It looked, I think, in the darkness under there, a trick of the light made it look like a rip. It's actually not. Okay, that could probably do with a clean on the inside as well. Let's cut that with some IPA, but I do not have any at the moment. But yeah, see how this outer red sleeve has sort of, I don't know, shrunk, or something, you know, it's just kind of slipped down. So then that's pulled off that sellotape there, which was stuck there. I've just restudied the circuit diagram. I got something quite fundamental the wrong way around. That the frame stage does feed into the scan coils first, then the scan coils feed into the convergence stage, not the other way around. Earlier I think I said that feeds into that, which feeds into that. No, it's that feeds, well, not necessarily that, but this stage feeds that, which feeds that. Look at the state of that. That is well and truly toasted. That is both barbecued and roasted. So which came first? Right, the heat or the moisture? Which came first then? The heat or the moisture? I'd say the heat came first, and then the moisture that caused the rust that's holding these pods together. Right. Reason why I've got that out is because the frame stage does also, once it's gone through the scan coils, the frame stage then feeds into here, into these 3 electrolytics here. The polarity is reversed. The positive is on the bottom because this side down here will have a higher voltage than this side up here. So yeah, it feeds into those. Either of those transistors could be faulty. That electrolytic could also be faulty there. But because they are because of the effect of these capacitors, I'm not to effectively decouple them. I'm not anticipating that a fault here or here would directly affect some of the frame output transistors. I don't know. I am still new at this hobby, but yeah, we need to look here. Also, it looks as though this then feeds down to there. Let me go back a page. Go back a page. Back to this one that's upside down. And that one, it goes down there, splits, and down there, and then also feeds into the frame shift. So there's 2 feeds actually coming from the frame stage. Again, I'm new at this, so that feeds into the scan coils, which then feeds into the so the convergence stage, that is actually fed on 2 fronts from the frame stage. It's fed via the scan coils from the output stage directly through there and then up to the convergence, but then it's also fed from the frame shift stage here. And I think that is for HT. Yeah, because that is the HT rail. It's passed through the frame shift pot and then upwards. So learning curve. Dead short. Not shorted. Not shorted. Not shorted. In fact, that one earlier, because I was just testing it just before I started filming, that one had also tested short. Wondering if it's... Oh, well, that's fallen off. That wouldn't help. See? Dead short. And 804, that one is 812. Those are up here. So 804 and 812. If we go, so they are there, down there, down there, down there, then they join up here. So these, as I think I showed you a minute or two ago, these go directly to the frame output stage. No wonder we're having issues. I don't know what, but something made me just retest these, and 813 is also short. So it's flaky because the legs on the capacitor are really dirty. That's why the beeping keeps coming and going. Yep. So we've effectively just got one massive short circuit across there, which means that those two resistors will likely have suffered. And looking at the ends of those capacitors, let me start again, and looking at the ends of those capacitors, they do not look in the first flush of health. Look at the crap leaking out the side. Look at that one. That's got to be the result of moisture ingress. And if you look at, as you've already seen, from the rust that's on here, that's definitely been subject to a damp environment in the past. Yeah, lots of white powdery stuff coming out the ends of these, especially that one. I could open them, once I'd taken them out, I could open them up and then sell it to crackheads, you know. That'd make them stop taking drugs, wouldn't it? Well, hopes dashed. It was a red herring. It's because I was testing them in circuit and resistor 808, which is only 5.6 ohms, was reading as continuity on my meter. It was reading as just the value is low enough to trick the meter into thinking that there's just straight continuity there, as opposed to 5.6 ohms of resistance. Tested the capacitors individually out of circuit. They are not short circuit, so the hunt continues. Well, after replacing all of those transistors and capacitors and other things, it's still the same. We are still the same, right? It's got to be the scan coils. It just has to be. Bollocks. Right, some major discoveries. First of all, I've got a week off work, so I've decided to test a theory of mine, which was that my citalopram was causing me lack of concentration. And it certainly seems to be, because my concentration has certainly gone up over these past few days. And I've been making a little bit of progress with this. First of all, this circuit diagram here doesn't have any voltages. It's the early version of the circuit diagram. It was the advanced released version, so which is what Pye, I nearly said Thorn then, it's what Pye gave, from my understanding, the advance service, not advanced, but advance service information is what Pye gave to their own agents, I believe, their own, their retailers, so that they could do warranty repairs. But that circuit diagram only, it has some voltages on other pages, but not for the frame stage. On another page it only has the oscilloscope diagrams, the oscillograms for the frame stage, not the voltages. So when you're doing something like this, when you're fixing a television, really, there's two things that you really need to measure: the waveform and the voltage. And you can sort of understand, I mean, the voltage will tell you quite a bit, and it will give you the voltage will give you some answers. It will actually, usually it helps you to piece together more of the jigsaw than the oscilloscope will do. Right. The oscilloscope, though, there's only certain applications where you have to use that, where you can't use this. And normally in a colour television you'd mainly use that, in a vintage colour television anyway, you'd mainly use that for diagnosing decoder issues, and sometimes some issues in like tuner circuits and that sort of thing, IF circuits and so on. And also if there's any particular kind of fault that affects the waveform but not the voltage. That is, the voltages are basically the last few pieces to the jigsaw of this. I've still got a thin white line on the screen whenever I switch it on, but we're getting closer, because originally it didn't, I knew that it was an advanced service manual, but for some reason I still don't understand why they didn't have voltages in this anyway, and just oscilloscope diagrams. My original interpretation was that you didn't need them. So if I thought that Pye thought that you didn't need them, why else would they be in any other version of the circuit diagram? Turns out, however, that the voltages are in other versions of the circuit diagram. This is the circuit from the Pye 715 chassis, which is a modification, an evolution of this. The frame stage is about 99% similar. There's a couple of component value changes around here, around this little bit, but it's 99% the same. So the voltages are going to be, the voltages in here are going to reflect to what the voltages in this should be. They're going to translate over. Now, let me just try and expand this. Yes, I've got an idiot phone, an iPhone, idiot phone. What am I doing now? I'm not playing anything. Right. Will it go that way? Will it shake that way? Yeah. So, now, first of all, I noticed that 14 volt line to the collector of the BC337 was completely missing. I will own up here, that was because the base of the BD234 was touching ground, so there was a complete short circuit. So there was nothing reaching that. There was nothing reaching the collector of the Pye CT200, which is the line output driver, I think. However, the output transistors don't seem to have suffered. Now that I've cleared that up, it's still not at 14 volts, it's only at 5 volts, so we've got something wrong there. And I think that that links into what I'm going to tell you in a moment, but just before I tell you what I think it links into, the output transistors don't seem to have suffered, because we have got pretty much bang on 14.5. I think it's like 14.2 volts at the output. Remember that used to be at 7, so that's been sorted out. Then here, that 30 volt line is actually 34 volts. 7.5 and the 9.5 are way too low from what they should be. I think they're about 2 or 3 volts. I'll have a look in a second. And here, everything is a bit too high. The 18 volts is at 20 volts. Which is, I would say, within the margin of error. However, the 1.8 volts is at 10 volts, and the 2.15 volts is at 9.3 volts, I think. So, collector on here is a little too high, but not too much to worry about. The base and the emitter are way too high. And on here, the collector is again a little bit too high, but the base and the emitter are way too low. And actually, yeah, so we've still got a few things to work out. It's not one single thing that's causing this fault, it's multiple things. And in fact, actually, I've just remembered, just before I started filming on here, I adjusted one of these. I think it was the height control. That actually got the emitter up to about 10 volts. I'm not plugged in anymore. I'm not connected up to it, but the multimeter is not connected up to it anymore, but that was at 10 point something volts on the emitter. So ballpark figure, right, we're almost there on that. So but we've still got too high a voltage here, I think. Let me just test it. Got it connected up to there, BC147 on the emitter. The manual on that said it should be 9.5, I think it said, so 10.4, so ballpark figure. And we've still only got a line on there, look, just a line. Right, so what does the base measure? It was supposed to be 7.5. 11, okay, that's a bit too high. Right, so could still be a fault with this. Reason why I'm pointing this out again after I've replaced it 2 or 3 times is because I discovered that there was a short from one of these pins to ground, and I've cleared that up, cleared up the short, but I've not replaced it. Maybe I should. That's one of 3 suspects I've come up with. Secondly, when I was reading up an explanation of how the circuit works in an article in Television Magazine, it said that the frame hold stage, I think, was essential in developing the sync pulse. So maybe that is still open circuit. I think I've already checked it before and it tested fine, but I want to check it anyway. And also I thought that maybe that sync separator chip was feeding complete crap into it. Maybe it was feeding way too high a voltage or something. So what I'm going to do to cut it off, see, because this should be a self-oscillating design, it shouldn't rely on the sync separator to work. It's a self-oscillating design. So if we either desolder the base of the BC148, or if we just desolder one end of that resistor, then we cut the frame stage off from the sync separator. So if the sync separator is causing it, then this will then start working on its own, because I'm wondering if this is feeding out so much crap that it's biasing. I don't know, but I'm thinking, that if maybe that's feeding out so much crap and there's too high a voltage that's reaching here, which means that this is not doing as it should. Right, so let's investigate that possibility. I've disconnected one end of that resistor, and there is a squiddly diddly squit of difference at all. Right, so the fault exists, I think, on here. I just want to double check the voltage there now that I've disconnected it, but I think that the fault exists on here. So the fault exists within this bit. Right, so with that resistor removed, the emitter is supposed to be, sorry, even with the resistor connected, the emitter is supposed to be 2.15. We're getting something like 9 or 10 voltages there, 10 volts there or something. Let's switch on, let's see what we get. Nil, not. Okay, is that connected properly? Right. With that disconnected, the dog says that we have 0, with that resistor disconnected, let me start again, we have 0, 0 and 20. Right. So at least we know that the transistor is not shorted then. Right, so the fault exists somewhere on here then. It's not up in it's not up in the sync separator. There may well be a fault up there because that voltage was still way too high, but we're still getting 0, 0 and 20. So yeah, that is definitely not shorted, and it doesn't seem to be open circuit, because when the resistor is connected we get voltage on the base and on the emitter. Of course, it could still be open circuit from the collector, could still be open circuit, so that may still be a possibility, but I want to check my soldering work around here, because I'm not used to doing printed circuit boards. I'm used to doing much older things like this, which had point-to-point soldering. So I think I need to check around here next. I need to check my soldering on that. Here we are for a circuit description. Straightforward SCS, this is from the July 1976 edition of Television Magazine. Straightforward SCS field oscillator circuit used in the Pye 713 chassis. This thing is shown in figure 2, which is actually below, it's down there. Positive going sync pulses obtained from a TBA 920 sync separator and line oscillator chip are integrated by resistor 702 and capacitor 701 and applied to the base of the sync pulse amplifier and inverter VT704. As a result, negative going field sync pulses appear at the junction, because it's an inverter, amplifier and inverter VT704. As a result, negative going field sync pulses appear at the junction of resistor 709 and 705 for application to the anode gate of the SCS, which is the four-legged thing, the funny looking diode. Following the SCS are two resistor capacitor charging networks, R716 and R717, which is the frame hold, and capacitor 714, which times the circuit, and resistor 71, resistor 719, which is the height controller, if I remember rightly, and capacitor 718, which develops the sawtooth field waveform. At the end of the flyback, both capacitors will have been discharged via the SCS, and since the current flowing through it will have fallen below the hold on value, it will switch. And since the current flowing through it will have fallen below the hold on value, it will switch off. Let me just try and process that again in my head. At the end of the flyback, both capacitors will have been discharged via the SCS, okay. And since the current flowing through the SCS will have fallen below the hold on value, it will switch off, okay. This permits capacitor 714 to charge towards rail potential, presumably it means HT rail. This permits capacitor 714 to charge towards HT rail potential via resistor 717 and resistor 716. Capacitor 718 likewise charging via resistor 719 and resistor 721. Since the time constant of the timing circuit is clearly shorter than that of the field charging circuit, the voltage across capacitor 714, so let me just read that bit again. Since the time constant of the timing circuit, is clearly shorter than that of the field charging circuit, the voltage across capacitor 714 will rise more rapidly than that across capacitor 718. Throughout the forward scan, therefore, diode 715 will be reverse biased, and it will be the voltage waveform developed across capacitor 718 that drives the emitter follower VT722 and the subsequent stages. An emitter follower is required here because its high input impedance will not restrict the voltage developed across capacitor 718 and to provide matching to the following driver stage. Okay. In the absence of sync pulses, diode 711 will be triggered on when the voltage at its anode developed across capacitor 714 exceeds the voltage at its anode gate. Right, so I need to check that then. So in the absence of sync pulses, diode 711, which is the four-legged thing, will be triggered on when the voltage at its anode developed across capacitor 714 exceeds the voltage at its anode gate, set by the potential divider resistor 709 and 707. It will then rapidly discharge capacitor 714 and via diode 715, which then becomes forward biased capacitor 718. In practice, however, diode 711 is triggered just before the end of the forward scan by the negative going sync pulse, which appears at its anode gate. Right. So yeah, remember, well, it was only a few seconds ago, but In absence of sync pulses, diode 11 will be triggered on when the voltage at its anode, developed across capacitor 714, exceeds the voltage at its anode gate, set by the potential divider resistor 709 and resistor 707. Right, so if there are no sync pulses, then the anode voltage should be higher than that of the anode gate. That's how I'm reading that. But it's not. When I tested the anode, that was at 11 volts, 12 volts. But when I test the anode gate, that's at 20. So, set by the potential divider resistor 709 and 707. I have a feeling I'm going down another rabbit hole here. So, but that is something I want to check. So there's now 3 possibilities here. I know that there were 3 possibilities earlier, but we've added another one. We've crossed one out and added another one now. So, still could be diode 711 that's gone faulty somehow. Could still be the frame stage. Of course it's the frame stage. It could still be the height control. So let me just start this again. Right. So possibility 1 could still be diode 711. Possibility number 2 could be the height control. I think it said either the height or the frame height or field control. I think it said in there. Timing is done by one, and then sync pulse generation is done by the other, or sawtooth waveform generation is done by the other. And thirdly, those 2 resistors it mentions, R709 and R707. In fact, let me just check capacitor 714 first. I think I've already replaced that. Well, I haven't, but it's that big red Mullard tropical fish capacitor there. They very rarely go wrong, so I don't think that that's going to be the main suspect now. I'll probably put that to being the last suspect. I want to check frame height, the height control, and also the vertical hold control. I want to check those 2 first. Then that, which is the weird 4-legged diode thing. Then those 2 resistors, and then that capacitor. So in that order. Right, major discovery time, and it's not good news. I've been talking with a couple of other members of the UK Vintage TV Collectors Facebook page, and what I did as a diagnostic test, because I just wanted to check again if there were any faults on the convergence board that could be causing this. So what I did was I unplugged the scan coils from here. I've plugged them back in since. I unplugged the scan coils. The picture was exactly the same, and I mean exactly the same. There'd be no shifting of any of the 3 coloured lines whatsoever, and something at the back of my mind tells me that they probably should have shifted. Goes down there, okay, because basically because this feeds some convergence voltages. I was going to say information just then, but remember, this is not we are way before computer data or anything like that with this, with a set like this. So yeah, so basically this feeds, adjusts for sawtooth or some kind of waveform that is then driven through the, if my understanding is correct, it's driven through the scan coils to provide fine information, fine tuning, if you like, of the 3 electron beams so that they hit the correct points on the front of the screen. You don't tend to get that on sets from the probably mid to late 70s onwards, because there were better ways, more efficient ways of making all the 3 pictures, red and black, green and black, and blue and black, all overlap onto each other. But the fact that when I unplugged this, it still did absolutely nothing, did not change anything on the screen at all, kind of speaks volumes. And most of these pots, I mean, there's 1 or 2 that will turn if you really push, but most of them, like this, this, in fact I've tried all of them, all bar 1 or 2 will not shift. Hang on, I've got a phone call. That was a wrong number. Anyway, so I think even if the frame fault wasn't on here, even if it was still down here somewhere, the fact that those can't be shifted renders this set as, I can't go any further with it. It's not that I'm unwilling, sorry, I was just saying, it's not that I am unwilling to, but it's just, it just makes no sense for me to go any further with it, really. I know that might appear or might sound the same, but it just doesn't make any sense. I mean, because that wasn't me farting, by the way, that was me, the back of my shoes rubbing against that. Yeah, it doesn't make any sense for me to go ahead with these in the state that they're in. With these in the state that they're in, oh, that one's suspicious. That one's the opposite, actually. That one is suspiciously loose. But anyway, with this, the state that it's in, it doesn't make sense, because remember, this set was never ever supposed to be fully restored. It was just trying to resurrect it, just for 2 reasons. 1, for a laugh anyway, and 2, to prove that the line output transformer worked for Ian and the tube worked okay for, and I'm sorry, I'm not being rude, but I can't remember your name, but I know that you commented on the on my initial post for this. So it doesn't make sense for me to get replacement pots just to get a picture on this. And Malcolm has offered replacement pots. Thank you, Malcolm, but it wouldn't make sense, because I'd be getting good pots putting them on that, potentially running the risk of, I don't know, ruining them, maybe a short circuit through them or something. And all for what? You know, a set that's going to be scrapped anyway. So there's no sense in doing that. So yeah, I think we finish it here with this. I've already been described as brave by some, crazy by others for attempting to do this, and it was a valiant effort, but here I haven't got a white flag, so I've got something that's white, so pretend that this is a white flag. Here I've got to wave the white flag. There's one more thing. Are my eyes deceiving me? Or does that scan coil lacquer underneath this sheet of plastic here, does it look as though that looks as though the scan coil lacquer's peeling off? Let me just turn the light off actually. Move that out of the way. I don't know, but that, see how some bits of it some bits like this side here, some bits are lighter and then some bits are darker. If the lacquer's peeling off, then that means that there's short circuiting somewhere in this. Short circuiting here. That's if I'm right, you know, I could well be wrong. Could well just be an effect to the plastic, but that doesn't...